are only one kind of methods, and they are all static methods. That means all of the methods are at the class level. That's why you were able to call a method from another class. And that's the reason that you were able to call it, because it was static and it was at the class level. Today, our main focus will be on non-static methods, means the methods that are written not at the class level, rather the methods that are written at the object level. So that will be the biggest difference between last week's class and today's class, that today we will focus on a little bit of object-oriented programming. But before we focus on object-oriented programming, it is not a bad idea to review some of the concepts we learned about last week. So I'm firing up Eclipse on my end, and you can fire up Eclipse on your end. So one of the things that we looked at last time was an example like this, practice. And this was a bit of a complicated example, as we were trying to reduce the amount of code that you will write and to remove unnecessary code out of the picture. So we coded a method called input, and it was a value returning method. And it's a static method, so it's just a class level. It's a class level method. So input, all it does, it creates a scanner object for which it requires a java.util.scanner to be imported. And then the input method simply asks a user for a number. And then instead of taking the number and storing it in a variable and then returning the variable, we just shorten that logic by saying, okay, as the value come in, return it right away. So it'll take the value from the user and return it right away. So when it returns the value gets returned to this guy. So this, he calls and he gets the value back. Then sum is still waiting to be called by the main. And then input, there's another input call. It completes the cycle, returns the value right here in the place. Now both parameters are full, so sum is complete. Now the call to the sum takes place. The first input goes in N1, the second input goes in N2, and then what sum does, it makes a call to another method, display, and to the display, it then automatically passes the sum of the two values that it received. Okay, so now let's get to the display method. The display method, as it receives the sum of the two values in total, simply displays the total. So technically speaking, you have a main method, the main method called the sum method, the sum called, the sum called the display method. And in order for the call to sum from the main would take place, main had called input twice. And those were the feeding values into the sum as parameters. So main called sum, but the call to the sum was only completed when two calls to input took place. And then the sum completed what it was supposed to do and made a call to display. So when display was done, display returned to sum. And when sum was done, sum returned to main. When main was done, your program ended. Okay. So that basically happened in this particular example that we did. Okay. Okay, so we have Lewis also joined us. Okay. So right now, I'm missing Ismail and Carter and Ethan. Okay. Okay. Any questions about this one? So let me create a new Java project called Unit 3. And this is where I'll be doing our today's examples. And let me right click and close all. This is how you can close all the open tabs. If you right click on the tab and hit close all. Give me a green check when you guys are done creating a project and you're ready.
When you create the project again, sorry, do we click on that? What button do we click on again?
You click the file menu and then you go to new option and then you choose Java project.
Okay.
And then you give your project a name and then you hit finish.
Okay, thank you. Button that use always tell us the hit so it carries the one thing over. What is that one?
Say that again.
When we create the project, you always said to click on the, is it the use?
Well, I ask you if you have an option that reads at the bottom module, make sure that it is unchecked.
Okay.
Okay, so the create module info should be unchecked.
Okay, yeah.
Okay.
All right. Thank you.
Okay, I'm sending a poll your way. It's still going to pop up in Zoom and can you answer the question? There's only one question in the poll.
I don't think you're going to find much opposition to that question.
Okay. So everybody said that's okay with them. Okay, just wanted to make sure, you know what I mean? Like, okay, cool. So to get started here, let's read the problem and try to solve the problem by breaking it down into steps. That will give you one of the reasons I wanted to do it this way, because some of you had questions about the homework assignment or were not sure about how to break it down or solved it incorrectly in the initial phase. So that's why I wanted to do this, so that it will be easier for you to then break the problem down in steps. So first of all, I will right click and name my class. Now that was also a problem with some of the students in this class and some in the other class, is that when you name your class, the problem clearly tells you what to name your class, and people were naming it whatever they felt like. So in problem number 11, it clearly tells you to call this one book billing. That's what we will name it. And hit finish. So step number 1 is done, which is the very last line. Save the application as book billing. Why did the author do it this way? Because the author is writing this book for those people who are working with editors where it doesn't let you save the file earlier on. There are some editors like that when you open a new file, it just opens a blank file and then let you save it afterwards. So I think she's targeting those people. Anyway, now let's get to the actual problem. It says, create a class named book billing. So she automatically addresses for us as well, because when you name the class something in Eclipse, it automatically gives that to be the file name. It includes 3 overloaded methods. So I should probably make a note of that. Outside of the main, I should create 3 overloaded methods. Okay. Now, what should be the name of the method? Compute bill. So I'm writing all these notes down for myself, so when I start breaking things down, it will be easier. Since it's a method, that means it will have parentheses. It wants me to create 3 of them. So 1 variation, 2 variation, and 3 variations. The first variation of compute bill will be the compute bill that has no parameter. And that's exactly what it says in the book. First bullet point, the compute bill receives no parameter. The second version of compute bill receives 1 parameter. So I have compute bill with 1 parameter. Again, this is just at the design level, okay? Then I have a third version of compute bill that takes 2 parameters. So I can just do 1, 2. I'm just giving some gaps in between them because this will be my playground area where I will be coding the actual methods. Now, based on what we learned in the past about creating a method, one thing I know for sure, that public static void will be there, followed by the name of the method, compute bill, and opening and closing curly bracket. And now that is the basic syntax. So I must have the basic syntax done. Then it's overloaded. What does that mean? All 3 methods will be same except for in the parameters, right? So let me first write them. I will fix the errors later on. So I have 3 versions of compute bill done. Is everybody following okay?
Yep.
Okay. So I have 3 versions of compute bill done. Now let me get to my second version. It says it should receive 1 parameter, and that parameter should be the quantity ordered. And quantity is usually a whole number. So I'll say, okay, let me call this parameter quantity. Somebody could have called it quantity ordered, perfectly fine, right? I could have, if I were to do quantity ordered, I will use camel casing. So I have both choices there. Some of you may shorten it to QTY, ORD, fine, okay. Now let's get to the third bullet point. The third bullet point says 2 parameters. The first one is quantity ordered. And the second one is a coupon value, right? So coupon value means it is a decimal number. So I will use double. So I have all 3 variations done. Notice all the errors disappeared. So far I have done part of the problem. Now it says that the main method will make a call. Main method will prompt the user. Now this was another problem. Somebody prompted inside the overloaded method. So that's clearly against the given instructions. The given instructions are prompt the user for the number of books ordered inside the main, right? So I got to be inside the main, and I will be creating my scanner object. And again, when it says input, I should right away from my prior experiences start coding these lines of code. That's why I've been telling you guys, it's very important that you do your assignments on weekly basis, because if you don't do these things and you only do in-class work with me, and all of a sudden you are like, oh, I want to do 3 weeks worth of assignment, it's a big no-no. Okay, so now I need to be able to accept an input. So it tells me that I need to accept from the user both things. So I need 2 inputs from user. What are the 2 inputs? Quantity ordered and coupon value. Okay. Each input requires some kind of a message. Please enter quantity ordered. So next int. And then please enter coupon value. And let's do this here. Double coupon value equal to input dot next double. Oops. Okay. Is everybody okay so far? What I did over here? Okay, so as you're noticing that I am trying to work on with different areas within my problem statement. So first I laid my basic foundation, and then I am building my main. Okay, now it tells me that the main will test the 3 overloaded functions. How can you test a function? This is how you test a function. Test a function means you call a function, right? That's what a testing means. So if the main makes a call to compute bill, that means you are calling the overloaded method with no parameter. That means automatically the call will go to line 20. I know it's empty right now because we have not yet started building it, but okay. Then I need to call the compute bill again, and then I need to call the compute bill again, but different versions of compute bill. So now I need to make sure that I pass to the second version, quantity ordered, and to the third version, quantity ordered, as well as the coupon value. Okay, so calling with 1 parameter and calling with 2 parameters. Okay, so far, everybody getting it okay? Any questions this far? Okay, now it's time to work on individual methods, because if you notice the problem, I took care of the first two lines of the problem and I took care of the last two lines of the problem. Now I need to work with individual bullet points. So let me go to the first bullet point. The first bullet point states that it receives no parameter. The method computes the price of one photo book. Computes the price. So double price, because I need to do some computation. What is the formula? The formula is that since it is one book, so 1 times the unit price of $14.99, okay, and it adds 8% tax to that amount. So let me now declare some additional variables, and then I will solve this problem a little bit better. So let's say this is the price before tax. Okay, this is the price before tax. I need to declare a constant final double, and this is my tax rate, which is 8%. So how should I write 8% in decimal?
0.08.
Yep. Okay. Now comes my actual computation, which is double price equals to price before tax plus, now I need to calculate the 8%, right? Which would be price before tax times the tax underscore rate, which is the 8%. So 8% multiplied by the price before tax will give me an amount. And I'm adding this amount to price before tax, and that will give me the price before tax plus the tax amount. Okay, now comes the actual thing. Look at the very last line. Return the total. So you cannot display it inside the compute bill. So I got to make some fundamental change. What would that fundamental change be? This void needs to now be double, because I have to do a value returning function. And there should be a return instruction over here with the value of price. What does that mean? That means compute bill will return a value, so main need to catch that value. So double price number 1 equals to whatever value is coming back from compute bill. Any questions so far?
Yeah, I guess you might have said this when you started doing it, but for the very first method we're doing,
Mhm.
is there a reason why you're doing a variable rather than just doing like 14.99?
Yes, I'm doing it like this. Oh, I mean, like declaring a variable for price, $14.99, and doing it. I could have done it that way too. But since here, yeah, I could have done it that way too. I could have declared a constant, not a variable. So because it's fixed, right? So final double, I could have done unit price equals to $14.99. And then I could have used that unit price like that. Anything else? Okay. So now that takes care of the first bullet point. Now let's get to the second bullet point. Again, I know that these are value returning functions. So right away, I am changing this to double. Now, the main difference between the first one and the second one is very simple. The second one says it receives one parameter. We already took care of that on line 30. It represents the quantity ordered and multiply the value by 14.99. So what is different over here is this, that it's the same process, except for the fact that instead of one, it is the quantity ordered. That's it. That's the only difference. So in the first one, we were calculating it for a single item. And the second one, we have the quantity ordered in hand. The rest of the process is the same. So now we can go back up here and we'll get the double price 2 equals to compute bill. Now comes the last one. Last one is even, it's similar, but with one additional information, that we need to subtract the coupon value before we calculate the taxes, okay? So now let's complete this one by first of all, making sure that this is also a value returning function. It's double. And then after that, we will work with one additional information. So price before tax. Quantity order times the unit price, that will calculate the overall price minus the coupon value. Okay, so it says that multiply the quantity by 14.99 and reduce the result by the coupon value. Then add the 8% tax and then return the total due. So that's the only variation here. So scroll back up. And now I have double price 3. Now main says test the 3 overloaded methods. So testing is inclusive of displaying the values that I'm holding, price 1, price 2, price 3. So I will have my system.out.println price number 1. Price number 2.
This class starts at 5:30.
And price number 3. Okay.
Oops, sorry about that.
Hey, welcome. Did you just come?
Yeah, I actually thought that this class started at 6, but I got it mixed up with my other classes.
Okay. So that basically how you will solve the assignment that is due tonight. So when you run it, it asks for the quantity ordered. And then it asks for the coupon value. And here we have the 3 pricings. So not all inputs will make their way into all calls. Okay?
Yeah, I can kind of see where I was going wrong.
Everybody followed okay here? Any questions?
Going down to the third method.
Yeah, going down to the third method. Okay.
Thank you.
So that is the only method which requires us to subtract the coupon value before we calculate taxes. So that's why we are subtracting the coupon value earlier on, and then we're calculating the taxes. That's good, Jacob. That means you're getting it. Now, I did it I did it by breaking down the problem in many steps. Probably depending on where you are in your level of programming, you probably might not have gone in that much details. Rather, after looking at the problem, you'd be like, oh, okay, this is how I'll do it. So I just took a little different approach. With trial and error approach, the reason I did the trial and error approach, like I purposely did not put the double there when I was creating my overloaded methods and wrote void, just to reflect upon some of the code that were initially sent to me, where students were making little mistakes here and there and not reading correctly into the sentences or keywords and missing out on details. So that's why I was walking you through the process. Okay, anybody else has any question? No problem. You're welcome, Jacob. You're welcome, Jonathan. So are we ready to move on to chapter 4? Okay.
Can I see just the section of code where it's just compute bill with no parameters?
Yep.
Okay, perfect. Thank you.
Mhm. So again, to sum it all up, we declared main with input logic. Then after accepting input in the main, we made calls to overloaded methods. And then the overloaded methods return the values back to us, which we then displayed. Okay, so now so we are missing Carter. And we're missing Ismail. Okay. So now we will be going into chapter number 4. This ebook is giving me a lot of these ebooks rather from Cengage. Sometimes they load, sometimes they don't. I was having this problem with my class, yesterday's class as well. Well, it was there. I think it takes a little bit of a time to load. Okay. So let me go back to chapter number 1, because chapter number 1 is where we first talked about chapter 4. Chapter number 1, understanding classes, objects, and encapsulation. What is a class? A class is a template. What is a class? It is a template, or it's a classification. What do you put inside a class? It all depends on the object that you're coding. So if I'm coding a light bulb, whatever defines a light bulb will go inside my class. If I'm coding a lamp, whatever defines a lamp goes into my class. If I am writing about dogs, whatever defines dog in the context in which I want the dog's information to be stored, that defines my class called dog. So looking at this particular example from chapter number 1, what information are we storing about dog? For example, if I zoom into this picture, okay. So this is my dog class definition. My specifications are such that I want every dog's name, age, breed, and shot status to be recorded and reported. So I will tell my class declaration that I want to store information about these 4 things about each and every dog that will come to this class. So my class definition will say that I have 4 properties. I have 4 properties for each instance of the dog. Or in other words, I have 4 properties for each object of the dog type. In simple plain words, in simple English, I have 4 properties to represent each dog. Okay? Now, these properties are not static. Why? Because static properties are those properties which have the same value for all objects of class type. Static properties are those properties that have the same value for all objects of class type. And if you start looking at this picture, each dog has separate set of values for the same properties. So these are called non-static properties. I'm trying to tell you the difference between when to code static and when to code non-static properties. So you will code non-static properties if that property will change for each and every instance. If it will be same for all the instances, you will call it a static property. For example, the name of the company or the name of the vet clinic or name of the dog rescue center, that will not change from dog to dog. The address of the location will not change from dog to dog. So I could keep it fixed. I could keep it static. Anything that will change from dog to dog, I will keep that non-static. How do you declare a non-static entity? Very simple. When you declare it, you don't write the word static in the name. That's it. You drop the word static, it becomes a non-static entity. So did everybody understand when to use static, when and when not to use static? Okay. So if the value will change from an instance to instance, do not use static. Now comes that, okay, so all these 4 properties, are they changing from instance to instance? And yes, it happened to be so that in this example, all dogs are up to date in their shot status, but their likelihood is that there may be a dog that is not up to date on the shot status. So the value will be different for that dog. So we should leave all these properties non-static. Okay. Now, once we understand that the class will have 4 non-static properties, now comes another question. How can I see the values? And the answer to that question is through the methods. Through the methods. Now comes another question. Can methods be also static or non-static, just like properties? And the answer is yes. If you want to display a non-static method, a non-static value, you must code a non-static method. And you'll be like, why? Why do I need to do that? Let me explain it to you why you need to do that. Because what happens is each one of these dogs create a different memory. So I have 3 memories, 1 for each dog. And each memory has 4 slots, 1, 2, 3, 4. Okay. Each one of them have 4 slots. Why 4 slots? Because each dog has 4 properties. So when I create a static method cannot say, okay, give me the name of the first dog versus give me the name of the second dog. It can't do that. It cannot go into the separate memories of each instances. But when I have a non-static method, it can do that. It can look inside the memory of individual objects. So when I call the non-static method, I need the name of the dog. Then the non-static method says, okay, who's calling me? If number 1 is calling me, I will look inside the memory of number 1. If number 2 is calling me, I'll look inside the memory of number 2. If number 3 is calling me, I'll look inside the memory of number 3. So what does that mean? That means the non-static methods are called by the objects of the class. And static members are called by the class itself. That's why the static methods cannot differentiate between the memories of different instances, because they don't have access to those memories. Does that make sense to you guys? Because this concept has to be very clear in your minds, walking into the object-oriented world, especially in Java, static versus non-static. So non-static entities can look inside the the memory of non-static entities, and static entities cannot do so. Okay, so now we have first dog, which is this guy probably. That is where this dog's information is stored. Maybe let me use a different color. Okay. So this dog is stored here, this dog is stored here, and that dog is stored here in different memories. So when I say 3, give me your age, so only this guy will be visited. When I'll say 2, give me your age, then this guy will be visited, provided that this is the name, this is the age, this is the breed, and this is the shot status. So I could literally go by properties. I can write my methods to work on each individual property. So I can have a separate method for this one, a separate method for this one, a separate method for this one, and a separate method. So each property can have its own method. Now you must be wondering, okay, so if I have 3 objects, do I need to code 12 methods? No. You'll still code 4 methods, because remember, the methods are called by the objects. The method names are written like a template. So if number 1 calls a method number 1, that means you're looking for the name of method 1. If method 2 calls number 1, that means you're looking for the name of number 2. If 3 calls number 1, that means you're looking for the name of number 1. Number 3. So depending on which of the 4 methods, which of the 3 objects call, then that method can only look inside the body of that, or the memory of that object. So it all depends on who's calling. The one who calls is the one whose memory is open or accessible to the caller. So the calling method only works on behalf of that object alone. Can't see anybody else's in that call. But in the next call, whoever then calls will be able to see into that caller's memory. So you will code 4 non-static methods, which then be called by objects. Whichever object calls, that's the object's value it displays. Making sense so far? Okay. Let me clear this. And let's get to actually coding this the way I explained it to you in Eclipse. So let's go to the Eclipse. And let's right click on the source to create a new class. What should I call the class? What should I name my class? What am I writing the application about?
Dogs.
Dog. So I should see, it tells you the name of the class is dog. Right, that's it. Okay. So I should call it dog with public static void main.
No.
Yes,
Okay, my bad.
yes. Otherwise, I won't be able to run it.
Yeah, I
So-
was just like thinking about like, polymorphism and all that. So
Oh.
probably was getting confused with that. So my bad.
Okay, no problem. Okay, so now let's say hit finish. So we have this guy. Okay. So dog is defined by how many properties? 4 properties. For each dog, which are name, age, breed, and shot status. Since the properties are for each dog, since properties are for each dog, the properties will be non-static. So public string name. Notice I did not use the word static. Public integer age. Public string breed. Public string shot status. So these are my non-static properties. To access the non-static properties, we need methods. So we need methods. Oops. To access non-static properties. Similarly, we need methods to display, or I should say change non-static properties. So for example, if the dog turns 5, I should be able to change the dog's age to 5. If the dog shot status is not up to date, then I should be able to change it to not up to date. So I need methods to retrieve the values, and I need methods to change the values, okay? So methods to access the values are called getters. Okay. Or they're also called accessors, but getters is what is preferred by Java. And the methods to change are called setters or mutators, but setters is preferred by Java. Okay. Now, getters means value returning method. So all the methods will be public, and they will have a return type, get, and the name of the property that you are trying to get. So you will simply return the property. That's it. Now, there are a couple of things I want to talk about here before I move forward. Number one, the return type of the getter will match the return type of the property. Okay. Number two, the word get has no meaning in Java. The only reason we write the word get is the writing convention in Java that the methods declared for getting the value of a object should start with the word get, because that's how I can visually look at it and know the purpose of the method. So all getters will have a return type, and all getters will return one property. How many properties do I have in this class? 4. Right? So for each property, I will have a getter. Public integer get age. And since age is an integer, therefore I'm returning an int. Public string get breed. It's a string, so I will return public string get shot status. And this is where you will see that Java is different from C#. C# doesn't do it this way. Any questions about the getters? Okay. Now let's move on to setters. Setters never return a value, so setters are always void. And setters are set followed by the property that you want to set. So public void set and the name of the property that you want to set. So since you are trying to set a property, that means you must pass a parameter. Okay. And that parameter can then be equated to the value, to the property. So property equals to the parameter. Likewise, I will write the setters for each one of them. Any questions about the setters? So if we were to look at the syntax of getters and setters, the getter syntax is public, return type, get property name, return property name. Okay, that's the basic syntax for a getter. What's the basic syntax for a setter? Public, void, set property name, some kind of a parameter that matches the description of the property, and then you set the property name equals to that parameter. So if you master the syntax, you can easily write any getter or setter. Any question? Okay. So now let me move down to the main method, okay? So let me create a dog object, okay? I'm creating a dog object, and this is the syntax of creating an object. Class name, object name equals to new constructor. This is the syntax that you have to follow every time you create an object. Have you seen any syntax like this before?
Yeah, it's definitely in C#.
No, here in Java.
The scanner.
Yeah, the
Exactly.
scanner.
Scanner, right? We scanner, class name, object name equals to new scanner. And constructor always has the same name as the name of the class. Okay. So based on this idea, we will write dog1 equals to new dog. That's it. Okay. Now I know that dog1 is there. And as soon as I write line number 46, automatically what I get is, let me reuse annotation. I get a memory. In that memory, I get like 4 boxes. 1, 2, 3, 4. Why 4 boxes?
Because there's 4 properties in the class.
Yep, because there are 4 properties in the class. Okay. Now, what is stored in these boxes? For a string, it's nothing. Null. 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 For a number, it defaults to what? 0. Okay, that's what is stored in those objects right now, because I never call the setter to set the values. Let's check what's inside before we start coding any further. So system.out.println, dog's name. Remember the scanner class? You would call scanner object.nextInt. We follow the same syntax here. It will be dog1 dot get name. Okay. And then we can say dog's breed is get breed. Dog's age is get age. So it's the same syntax if you're following, right? So when you run it, check your output. All the strings are null and the number is 0. And let me add the fourth one as well, the shot status. And the dog's shot status is dot get shot status, okay? And here are the 4 outputs. And this is the whole reason you write a constructor, because in the absence of a constructor, your object is populated with the default values that the data type has to offer. And the whole reason of writing a constructor is you do not want to settle with the default values. You want your own default values.
Can you scroll up a little bit, please?
Scroll up
Yeah,
more.
a little bit more. I just want to see the where you started the last. That's fine.
All the way to the top? Okay,
No.
No.
Just scroll down a little bit, right there.
okay.
Thank you.
Okay. So did everybody get to run this and see the output? How about you guys? Miguel, Daniel, Tatiana, Desmond, Jack.
Yeah, mine's fine.
Okay. Now let's change these values before we display them. So dog1 dot set age to, let's say, 10. Let's change only one property. Dog1 dot set age to 10. And once you do that, rerun the program. Rerun the program, and you will see that the age is not 0 anymore. The age is 10. So you use the setters to change the values of the properties, and you use the getters to get the values of the properties. Okay. Now let's say dog1 dot set name. Oops. I'm just leaving the double quotes like that. Okay. What do you think will be the output? Will I still get null?
No, you'll get
blank.
mostly just a blank space.
It's just a blank space, right? Okay, so that's the difference between null and double quotes. Null means no value, and double quotes like that means it's a string. It's not null, but it's just like nothing. Nothing in there. Nothing versus null. Okay, now let me replace that double quotes with Ginger. Save the changes and run it. And now the name is Ginger. I can follow the same trend for shot status. Oh, sorry. Set shot status. And I can up to date. And dog1 dot set breed to Akita. So all 4 values are changed. So the whole idea is you conceive the real world objects, and then you model your template based on what you want to store about those real world objects. Then for each property, you write getter and a setter, and then you call them. That's basically the bottom line of an object-oriented programming. Take the real world idea, write down its properties. For each property, write getter setters, and you just call them, and that's how you test them. Okay, now let's take this example to the next level by incorporating something we learned in previous chapter. Let's go back to bookbilling.java, which we did earlier today, right? Okay. Now maybe I should go to unit 2. Oh, here you go. Okay. This is an example we did last week, methods example 1. So we are calling input, right? We're calling input. What is input receiving?
A
What-
string.
Elaborate more. Use
Oh.
some object-oriented terminologies in giving your answer.
It's a parameter that inputs calling.
You did not use any object-oriented terminology in that.
Could you repeat the question?
Explain this, what I've just selected, by using some object-oriented terminologies.
You said a parameter?
Parameter is a procedure-oriented programming terminology. If you just say the word parameter, it's not new to object-oriented. So you will still use the word parameter, but I need some object-oriented words in that explanation. So input method receives a parameter. Okay, now complete the sentence. Receives a parameter. Okay. So input receives a parameter of class type string, or in other words, receives an object of string type. See, now I'm using object-oriented terminologies here. So I'm differentiating between the nature of the parameter, that it is not a primitive type, it's an object type parameter. And what exactly does that tells you? It tells you that just like you can pass parameters of double or integer type, like I did in compute bill, I passed integer and I passed integer and double. Exactly the same way I can pass objects. Do you guys follow that? Primitive types can be passed as parameters, and class types can pass as parameters.
So what differentiates it from being a primitive type and a class type?
Aha, here comes the difference that we will be looking into here. is when a class type is passed as a parameter. Now that class type is not one value. Remember, your class is an object. So that means you're not passing one value, you are passing many values. So for example, if I pass a dog as a parameter, I'm passing the name, I'm passing the age, I'm passing the breed, and I'm passing the shot status. So that's what makes object passing different from primitive type passing, because variables are single valued. Since I said that I am passing multiple values, that means I can now use each one of them to call their getters and setters. With primitive type values, I can't call any functions on them. They're single values. I just simply say system.out.println, give me the age, and it will give me the age. But here, I cannot just say, give me the dog one. I have to say, give me dog one dot get age. Give me dog one dot get name. Give me dog one dot get status. So that's the main difference between passing parameters of primitive type versus reference types. Okay, now let's go back to dog. So right now, how many dog objects do I have in the main? Four. Only one, right? Okay. So if I declare another one, this is how I'll do it. If I do another one, this is how I'll do it. How many lines did I write to display dog one? Four. That means I would have to write 4 for each of the objects. Dog 2, I'll need 4 lines. Dog 3, I will need 4 lines. And that means if I have 5 objects, I would have to write 20 lines of code just to display their output. If I have 10 objects, I will need 40 lines of code to display the 10 objects. That's too much code.
So this would be a good time to insert a method, right?
Very good. That is a good time to create a method outside of the main, which will receive an object of dog type, public static void display dog. And then we will pass it a dog parameter, just like that, okay? And I can simply select these 4 lines and I can cut them out of the main and I can move them inside display dog, just like that. But I will make one change. The local object is called dog, not dog one. So I'll just fix that, just like that. Now, let me first complete, and then I'll explain to you what's going on here. So if I want to display a dog, I will simply call display dog and pass a dog object. It's the dog one and dog. So we have a dog one, which has its memory. And we have a dog that has its memory. So here we have values that are transferred from dog one into dog. So all the 4 things that you had in dog one are now here in the dog. So if dog says get name, he's getting this guy because that's the guy copied over from there. If the dog says get breed, he's getting the breed, which basically is getting it from the blue memory versus red. That's what it got it from in the original place. Age, that's the one that he got it from the dog. So yeah, he's just getting it from here, and shot status. So dog one, if copies into dog, now dog is a replica of dog one. On the next line, if I say, you know what, I want to call display dog again, but this time I want to pass dog 2. So now in the next call, dog is a replica of dog 2. Each call, dog comes into an existence. At the end of each call, the dog object disappears from the memory. If I make another call and pass dog 3, now dog is acting on behalf of dog 3. So each call, dog gets defined, and at the end of the call, dogs get undefined. So this way, I can save myself from having to write the same lines of code over and over again inside the main. Now, if I run this program the way it is right now, notice that only dog 1 is populated and dog 2 and dog 3 are all nulls and 0 because we never called setters on them. So if I were to call setters on dog 2 and setters on dog 3 again, it will be like I'm repeating myself. So that's another good candidate. Public static void fill dog data. Okay. And then it will receive some parameters, and those parameters, like it will receive name of the dog. It will receive oh yeah, I can change it. Age of the dog. It will receive breed of the dog, and it will receive shot status. Those are the 4 things I can pass, right, as parameters. And then all of this information that I have over here on line number 50 through 53, that will move inside fill dog data. And I will replace the hard-coded values with the customized parameter names. So I'll cut it out of there. I'll paste it here. Oops. And sorry, first of all, oh, one more thing. I would have to pass also the object, right? So I need to pass the dog so that I know that's the dog who is receiving all of these things, right? So the dog age is this. Or I can do this. Hold on a second. I'm better off, instead of passing dog like this, I'm better off doing something else. Let me create a value returning function of dog type. I think that's better. I could populate a dog, and then I can return a dog object. That way we will be also able to cover that topic. So the first one was a void method, which was receiving a dog parameter. The second one is a value returning function, where we are sending the dog object back to the caller. So we will replace that with age, replace that with the dog's name, replace that with the dog shot status, and replace that with the dog's breed. So I call the fill dog data. I pass the 4 parameters, the name of the dog, the age of the dog, the breed of the dog, the shot status. I declare a local dog object, which I'm using as a temporary memory. Fill it with all the data. So create a box over here, a local box with 4 values, 1, 2, 3, 4. And then pass that box back to the main, where main will take that box and dump all the values in the local object, which we will still need to write. So up in the main, I can say dog1 equals to fill dog data, and I want to pass Ginger 6, Akita, and up to date. Dog 2, Bowser, 2 years old. Retriever, up to date. Dog 3, Roxy, 1, up to date. So when I run this program, now check your output. Zach asked a very interesting question. Why would the fill dog data method be static? The reason it is static because the fill dog data method is not a method that is working directly with the class properties. It is simply working at a class level. What do I mean by that? That means the class is using this method to pass some properties, fill those properties inside an object, and return that object back. So the method is not directly working with a class instance or class objects. So it doesn't have direct access to the class object's properties. So the method is not at the object level, rather the class is using that method to do its job, as opposed to an object using the method to do its job. So the method is not available at object level. The method is available at class level, just like display dog. Display dog is available at the class level. So we are displaying only the object that we are passing. Similarly, the fill dog data is of the same reason. Now comes the question, can I do the same stuff by using a non-static method? And the answer is yes. There is no fixed rule that the displaying of the object must be done through static approach. But when you display the object through a non-static approach, then we have to write a different kind of a code, which we have not yet learned. Similarly, if you are filling an object as a non-static level, we write a different kind of a code, which you have not yet learned. So you can do it both ways. So right now we are learning how you can display an object at a class level. I don't know if that makes sense. Okay. Okay, everybody got this? And the people who didn't say anything, are you still coding? Is anybody still coding? Let me put it this way. If you are still coding, please let me know. Okay. Now let's scroll back up into the class and let's create constructor method. Constructor. And remember, constructors never have a return type and they always have the same name as the name of the class. What is the purpose of constructor? Constructors are created to initialize class objects. That's the only reason that they're created. So I have name. I want to set the name to R. I want to set the age to 8. I want to set the breed to retriever. And I want to set the shot status to not up to date. So I have created a constructor that instead of having null, 0, null, null, every time a dog object gets created, these will be the default values that it will receive. Then the dog object can call setters or call some kind of a method to change things. So after I create the constructor, let me scroll down to the main. And let me create a 4th dog. And let me not fill the 4th dog with any data. Rather, let me directly call the display dog on the 4th dog. So I did not fill dog with any data. I declared the dog for, and I'm calling the dog for to display data. So now when you run this, check your output. Notice the last one, the dog number 4, his name is R, his retriever is 8, and is not up to date in shots. So what happened now is, instead of having meaningless values, constructor allows you to give some meaningful values to objects to start with.
It's basically a default value.
Default values, right?
Yeah, that's what, it's kind of like the default at that
Exactly.
point.
Exactly. And you cannot call constructor after the first time. You cannot forcefully call this method. All other methods can be called more than once, but constructor can only be called once, which is at the time of creation. So the whole purpose of constructor is to initialize the object with its initial values or default values to start with, so that the garbage values are not there, and the programmer can customize what values the programmer wants to start with. Okay, got it so far? So good, everybody?
Can you scroll back up to the top?
Yep. So what did we learn about the non-static methods? How are they different from static methods? The non-static methods work at object level. What does that mean? They work at object level. It means if you want to call a non-static method, you first write the name of the object, then you put a period, and then you call the method that you want to call. So I cannot directly call get name. It's non-static. I have to first say dog1.getName or dog2.getName. I cannot directly call getName. So since an object calls the getter or an object calls the setter, that method getter or setter can only look at the calling object's memory. It can only look into the calling object's memory. So that's why when you say get name, give me the name, and why does it not get confused? Because it knows the caller. It can only look into the caller's memory. Okay. Now, Desmond, you're done with the top?
Yes, sir. I just wanted to recheck something.
Okay. Now let's come down to our setters, and let's make some difference here. Let's make some change here. Okay. Line number 37. Instead of N, I want to call it name. What happened as soon as I put name on line 37 instead of N? Two things happened. Can you tell me what two things happened?
You got a red line underneath the
N,
N,
right? Because
and then the name highlighted.
and because the name is it doesn't exist, right? The N doesn't
Right.
exist. Okay. And the name got highlighted. Okay, what else happened with that highlighted name? Something else happened with that highlighted name.
Turn yellow.
Its color is different, right? Its color is different than the color of age, breed, and shot status, right? Okay, now there's an indicator. So now I'm saying name equals to name. What am I really saying? I'm saying I want my parameter name to be assigned back to itself. I'm not changing the class property. I'm simply assigning the parameter back to itself. So to assign the property, the value from the parameter, Java developers, first of all, instead of declaring too many names, They name the parameters exactly the same as the property, and they precede the property by a special keyword called this. And what does this means? So as you know, that the setter was called by some object, dog1.setName or dog2.setName. So the guy called this refers to that object. That's what it means. So name of the object, whatever object called, the name property inside that object is what I'm setting with the name. So this is a built-in keyword, and this keyword pretty much means the calling object. Okay. Similarly, I can make the same changes all the way through. This dot age equals to age. This dot breed equals to breed. It helps me not having to define too many names. And this dot shot as status equals to shot status. When you run your program, will run exactly the same way. But according to the Java writing conventions, the parameters for setters should have the same name as the property, and you must precede the property by this keyword to differentiate between parameters and properties. Okay. Now comes another question that can I overload the constructor just like I can overload other methods? And the answer is yes. And now comes another question. Why would I want to do that? The reason I would want to do that is because sometimes I want dog to be initialized by programmer defined values. And sometimes I want to define those values at the user level. I want the user to tell me what he wants as the name, what the user wants as the age, what the user wants as the breed, what the user wants as the shot status. So in that case, I will do the same thing as I did before. This dot name equals to name. This dot age equals to age. This dot breed equals to breed. And this dot shot status equals to shot status. So overloaded constructors are just a way for user to control the default values versus programmer hard coding the default values. Just customization. Okay. Now we will put this to test. So we're going to go down in the main and we'll create a dog5. But this time the dog5 will not call the default constructor. This is my default constructor. And this is my overloaded constructor. So my dog5 will call the overloaded constructor. So let me scroll down. And let me declare dog 5 equals to new dog. And it'll take 4 parameters, right? We're going to have a name. We're going to have an age. We're going to have, breed. And we're going to have shot status. Okay, 4 parameters. Okay, can one of you give me the name of a dog?
Spot.
Spot. Okay. Can one of you give me the age?
5.
5. Okay. How about breed?
Husky.
Oh, is it Y or IE?
Why?
Y. Okay. What about shot status? Up to date or not up to date? Or not
Up to
sure?
date.
Up to date. Oops. Up to date. Okay. Now let's call display dog and let's display the dog. And when you run it, notice the very last one is spot husky 5 up to date. So the user controlled the values that he wants or she wanted this object to be initialized with. And those are the values that were displayed. You can change if you want to change one particular property or, more than one property. So for example, if I want to alter the age of dog 5, I could literally write here dog 5 dot set age. I want the age to be 8. So after you make the change on line 68, rerun the program and notice Spot is 8 years old. So I overrode one of the default properties. Okay. Now let's recap what we learned about in this one class that we have worked with. We created a class called dog. We defined 4 properties. We created a constructor to put default values for every instance of dog. We created an overloaded constructor in which we gave user the choice of coming up with the values to initialize the object. We wrote 4 getters, 1 for each property of the dog, so that I can retrieve that property. And we wrote 1 setter for each property so that we can change the property of the dog. Then, since the parameter name and the object name was exactly the same in the setters, we used this keyword with the property to differentiate it from the parameter so that we know that the parameter's value is going in the property of the object, not the other way around. Then inside the main method, we created 5 instances of dog. And instead of populating the data and displaying the data, everything in the main, we created a couple of modularized methods. One method receives a dog object, and after it receives a dog object, it then displays the 4 properties of that object. And the other one, when it receives values, it populates a local dog object and return that back to the main so that that object could then be assigned to local objects. And that's exactly all we did in this example. That's it, right? But there are little concepts that you need to pay attention to when you're starting to code as to what this concept will do and what that concept will do. So in a nutshell, I would say that we did most of chapter 4 concepts, but we're going to be doing more than one example. This is just one example because I think one example, if you see more examples, the things may get a little bit more clear to you. So does anybody else has any question about this particular example? Everybody got this up and running? Okay. Any questions, anybody about this particular? We basically took this picture and then we coded our example based on this picture. I hope nobody is going in this direction. Okay, as long as I didn't give you a headache. So let's start with a new example. Fresh start. Let me close all the previous work. In the same project, unit number 3, we will start a new class. The name of this new class will be employee with a public static void main. And we hit finish. Okay.
How do I create a new file so I can put these classes under unit 3?
You mean you want to create a new project?
Oh, it's a project.
Yeah,
Okay.
unit 3 is a project. So you click File, New Java Project.
Okay, perfect. Thank you.
And then make sure that when you give your project a name, make sure you uncheck Create Module checkbox if you have that.
Okay.
Okay.
Perfect.
Okay. So now I will create a property of an employee. Can you give me one property of an employee?
Employee ID.
Employee ID.
Yeah.
Okay.
ID.
So usually when we create properties, we want to keep them hidden. We do not want direct access to properties. So we traditionally create private properties. Private integer employee ID. So let me put some comments here. Properties, constructors, getters, and setters. Okay. So I just created those comments so that I know I need those 4 items in my classes. Unlike C#, we don't have the concept of field and property different. You guys probably have done some C# programming. It's a little bit different in Java than it's in C#. Where in C#, everything is packed inside a property, the getter and the setter and everything here is not like that.
Yeah, because if you're doing C#, it's usually you just do property, whatever, and then it's just get set.
Exactly. Yeah. So there are some differences, of course, based on the nature of the language, but the idea is the same. The reason the getter is there so that you can get a value. The reason setter is there so that you can change the value of the property. Okay. Having said that, we want to create a constructor. Public employee and emp ID equals to 100. And let's create an overloaded. So this is my default constructor. We will also create an overloaded constructor, which will take one parameter called emp ID, and we will use the this keyword to set it up. So as you have probably started seeing that it doesn't matter what is the nature of the class, the syntax of the code is on the same grounds. The constructors are created very similar to each other. The overloaded constructors are created very similar to each other. So you should pay more attention to learning the syntax than memorizing the examples. Okay. Getters will be on the same principle. It's a getter, so I need a return. So public integer get emp ID, and it's a return of emp ID. And the setter is public void set emp ID. And this dot emp ID equals to emp. Okay. Now let's scroll back up. Can you give me another property for an employee?
Name.
Private string emp name. So I will create my employee with emp name equals to Sam. Now I want to have two additional overloaded methods, overloaded constructors. One overloaded constructor will set the employee ID to 100 and will only change the emp name. And then the second one will let me change both of them. So I'll have 4 overloaded constructors. So like that. So I have one which takes no parameter, one that takes one integer parameter, one that takes one string parameter. Okay, and this one, which only takes an integer parameter, I will set the employee name to Sam. So the one that takes integer parameter, the name is Sam. The one that takes employee name, the ID is 100. And then we have one that allows me to customize both of them. So overloaded 1, overloaded 2, overloaded 3. Okay. So we have one with no parameters, one with 1, one with 2, sorry, 2 with 1 and 1 with 2. Can you guys try writing the getter and setter for employee name yourself? Okay, give it a shot, give it a try to see if you can write the getter and setter for employee name.
Would you mind scrolling up just a bit?
Sure. Good enough?
That's perfect. Thank you.
So since employee name is a string, so my getter should be returning something of type string. And similarly, my setter will be accepting a parameter of type string, and then we'll be assigning the property emp name to the parameter emp name, like that. Was everybody able to do that? Now let's go to one question that Zach asked earlier on, that why are we not displaying the values through a non-static method? And I said, you could do it either way. So we looked at in the last example, how you can display the values using a static method. Now we will code a method inside the class, a non-static approach to displaying values. Such functions, which are neither getters nor setters, are called auxiliary functions, auxiliary methods. So auxiliary methods are those methods which are for general purpose use. So public void display properties, and I can just call it whatever I want to call it. I can call it display employee or display properties. I think display employee will be a better choice. Okay. So in this, since it's a non-static method, an instance of the class employee will call it, and whichever instance calls it, it will automatically only display the property values of that instance. So that's why I do not need to give it any instance reference, because it's non-static. It will automatically know who is calling it, so it can only tap into that caller's memory. Similarly, I will create an auxiliary method to change all the properties. So public void change all emp properties. So I need to pass an employee ID. And I need to pass a name. So in this one method, all I will do is I will call the respective setters. To one of them, I'll pass ID. And to the other one, I'll just pass name. So this is one-stop shop to change all properties in one shot, as opposed to calling individual setters. So this is equivalent to fill data method that we did with dogs. But since it is non-static, all I need to do is just call it with an object provided with values. So when the setters are called, it will make sure the setters are only updating the calling object. So that's the beauty of non-static. They only work on behalf of the caller. Oh, okay. Now let me go to the main. In the main method, in fact, we're going to go to the main in the end. I still have one more change to make. I need to condense the code that we wrote up there a little bit more by teaching you one more feature of Java that was introduced a few years ago. So let me scroll back up to where your constructors are. If you notice, all the constructors are pretty much doing the same job, right? They all 2 lines and 2 assignments. So we can easily condense this code by using a special method called this. This is a special method which allows one constructor to forward the call to another constructor. Out of the 4 constructors, which one is the most customizable? Default, 1, 2, or 3?
The default?
Default is the least customizable. See, all
The
the values
third
are
one?
hard-coded. The third one is the most customizable. So you always forward all calls to the most customizable one. So what employee will do, I will delete these 2 lines after I write the third line. It'll make a call to this method and will pass 100 and Sam. Oops. Okay, let me delete this. So this is a call to line 23. Similarly, the overloaded 1 will also call this, but will pass employee ID and Sam. This one will also overload, will pass 100 and employee name. So this is how you can make, instead of writing the same piece of code over and over again in each constructor, you can make all constructor simply make a call to the most customizable constructor. Okay. Now let me introduce over here a class level property. These are all instance level properties. That means every instance will maintain their value differently from other instances. We'll now introduce a class level property. The value will be same for all instances of class. And this will be a public static integer variable called employee count, which is initialized to a value of 0. So what I want to do is every time an employee object gets created, I want the employee count to go up by 1. Okay, so if there are 4 employees, the value will be 4, and it'll be 4 for everybody. It's not like it'll be 1 for the first one, 2nd for the second one, 2. So it'll be 4 for everybody. Now, my question to you is, where in my code should I increment the value of M count by 1?
Into the most customizable one.
Yep, into the most customizable constructor. So M count, because everybody is calling him, right? So eventually he's the one that gets called by everybody. So that's where, as soon as the object gets initialized, increment the employee count by 1. Okay. So far, so good, everybody? Okay, now scroll down to the display employee method. So every time I display an employee, it will show me whatever the current value is. Now I'm in the main. Employee E1 equals to new employee. So I'm instantiating an employee instance, right? And I'm calling the default constructor. Right away, let me see what values are displayed. E1 dot display employee. Let's run it. And here you go. It says current employee count is 1. Employee is 100 and the name is Sam. That's the default. Right? That's a default constructor. We will repeat the process 1. We'll change this to 2. I'm going to change this to 2. And this time, let me call by passing an ID only, 522. So I'm calling one of the overloaded functions. Now it says, you know what? The employee count now became 2. And this is employee ID 522, where the name is still Sam. Okay, now let's try to create 2 objects in a row. So object number 3 and object number 4. But for object number 3, I will going to only pass the name. And for object number 4, I will pass the ID as well as the name. Now let me call display on both of them one by one. 3 and 4. Now run it, and you will notice that it does create 4 objects, but why does it never displays employee count 3? Why does it displays 4 twice?
Because we displayed after we created this fourth employee.
Exactly. So since we are displaying employee 3 after we create the 4th employee, so the count is at the class level. So that means if the count changes, it changes for the same number for everybody. So employee number 3, when he comes to be displayed, there are 4 objects running in memory. So that's why the count is 4.
When I try and run mine, it says editor does not contain a main type, but I have a main method.
I probably know what's wrong, but can you share your screen? I'll be able to direct you better.
Sure.
Okay, here's the problem. Both of your classes, dog and employee, click OK. They must be inside the SRC folder. They are sitting outside the SRC folder. So drag the dog and drop it on the SRC folder and repeat the same for employee. Yeah. And now close the tab here. Yeah, close this and close. Yeah, I mean, like, and now double click to open employee again. And then we will fix the problem. Okay. Well, you have some errors there, the syntax error. So let me show you my code so that you can fix those errors. So there are some syntax error with double quotes and stuff at the top. You have your double quotes outside the parentheses versus inside.
Oh, okay, I see it. Okay.
Do you have any more errors?
Yeah, on your line 22, it's the same as mine, but oh, actually, no, it's not. I had 100 as string. And alrighty.
Got it? Okay.
Can you scroll down to the change all emp properties method?
Mhm.
Okay. Alrighty. All right, I should have all of them ironed out now. Getting a different error now.
Which line is it giving you an error on?
When I it would be your line 60.
Line 60. What is the error message when you hover over?
The value of the local variable E2 is not used.
Oh, it's a warning. So look at your line 61. Your line 61 might still be E1 dot display employee.
Oh, okay.
So if it's an orange line, it's a warning. If it's
Oh, yep.
yeah, it's an X. It's an
Okay, perfect.
Everybody else got it too?
All right. Thank you.
Mhm. Okay, then we will move on to a new example where we will learn about the built-in classes of Java, especially the math class. So Java built-in classes 1 with a public static void name. Math class in Java is very similar to that in C#. So it has methods like square root for square roots, round, seal, tangent, those kind of methods, like, it has like several methods for different mathematical needs. So we're going to be using some of those. Similarly, it also has a POW for power. And all these methods are same in C#. You probably would have seen them in C# as well. So for example, if I have an integer, num1 equals to 81 and double num2 equals to 81.44, let's try to take the square root of these values. So we have system.out.println, and we'll do math.square root of num1. And now let's do math.square root of num2. So for num1, the square root is 9.0. And for num2, it is 9.024 because it's not a perfect square. So as you notice here, Java follows the same syntax that it preaches you, the class name dot the method name. And since there's only one word, all letters are lowercase. Now, if I want to round my answer, let's say 9.024, if I want to round it, then I will put math dot round, around math.sqrt. Just like that, probably. So math.round has its parentheses that are around math.square root. So make sure you balance your parentheses. And now it just gives you 9 because it just truncates the decimal part completely. So what's the next perfect square after 81? After the 81, it is
100.
100, okay? So instead of 81.44, let me make this one 95.99. Now 95.99 will return a value which is less than that's more than 9.5. That's why it is rounding it to 10. It's rounding up, right? Otherwise it'd round down, depending on what the decimal placeholder is. On the contrary, instead of math.round, if I do math.floor, it will always round down to 9.0. Math.floor always round down, or math.ceil always rounds up. Math.round depends on the decimal. What is the formula for the area of the circle?
3.14.
No, the whole formula.
Oh, my bad.
It is the pi
Yeah.
times
Radius.
radius what? Square. Right?
Squared.
Pi r square, right? Okay. So we will calculate the area of the circle provided that somebody gave us a radius. So let's say the radius is given to us 6.5. So now I'm calculating area equals to, we have a built-in function, a built-in constant in the math class called pi, multiplied by, we don't have any exponent operators in Java like C#. So we use a built-in function of math class called POW, to which we give the item and however much power we want to compute for that item. And then we display the area. Similarly, you can use math.random, which usually generates a random number between 0 and 1. So it's a very long decimal random number. Very long number like that. So if I want to generate a random number between 0 and 10, so I can simply multiply this by 10. And now whenever I run it, I get a different random number between 0 and 10. But if I want to get rid of this decimal part out, then after I compute the value, I can round it. And that way I can have a random whole number every time. Okay. So we will now save this example as Java built-in classes number 2. So I just went to the file menu and I hit save as Java built-in classes 2. I'll get rid of all the code in the main method and I'll just simply rename it to Java classes 2. Okay. Okay, now let's work with another built-in class called local date. Local date. Now, local date doesn't have a constructor to grab you the current date. Rather, it has a static function now. How do I know it's a static function? Without even looking at the documentation, I could tell right away that now is a static function. How?
Is it because it's italicized?
No, it's because I'm calling it with the class name, not the object name. Okay. So all the methods that we looked at in the previous example, these were all static. See, round is called by class. Square root is called by class. Pal, class. Random, class. What was the example of a non-static function? Look here. Next int is non-static. How do I know? Because non-static is being called by an instance of the class. Do you guys follow that? If an instance calls a method, the method has to be non-static. If class calls the method has to be static. Now, here's another indicator. If you hover over now on your computers, do you see a green circle? And what do you see on the right-hand side of that green circle?
A red S.
That means it's a static method. Okay. Now, in the book billing, I will hover over next int. Do you see any S on that green circle?
Nope.
No, it's non-static. But a better visual is that you can tell right away if it's a class name, it has to start with an uppercase letter. If it's an instance name, then it'll be in camel casing. So who calls the method defines the nature of the method. Okay, so and here you go. It just displays the date. So now I want to have a custom date, not set to current date. So I can say, well, local date, graduation date equals to local date dot off. I'll be 2023, May 17th. Now GD, and here you go, May 17th, 2023. Is off a static method or non-static? Off.
Static method.
Static method. How do you know? Because it is called by the class local date. Now let's learn how you can extract things out of the date. Okay. So I will only extract the month. So I'll say graduation month is Can you tell me get month value? Is that static or non-static?
Non-static.
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 Right? Why? because it's being called by the instance of the class, not the class. Graduation certificate will be mailed on GD dot plus weeks, and let's say 3. So notice it automatically computed what will be the date 3 weeks from May 17th. And plus weeks, is that static or non-static?
Non-static.
Non-static, because it's called by the instance of the class. Yeah. Okay, everybody with me so far? Okay, now let's create a new class. And the name of this class will be, let's say mug. Public static void main. Private integer mug ID. Private double mug price. What am I coding right now on line 7 through 9? What is that?
Default constructor.
Constructor, very good. Okay. And what kind of constructor am I coding right now?
An overloaded constructor.
Overloaded constructor, awesome. Can you tell me what kind of calls should I have, or what kind of code should I have inside the other 3 constructors?
The first one just set mug ID and mug price to a default value?
Something we learned in employee.java, remember? The this calls. Okay, so we will just have a this call. And in this one, we will just hard code some values. Oops, not string. And the second one, we will pass the mug ID, but we will hard code the price. In the third one, we will hard code the ID, but pass the price. Okay, good. Okay, can you guys code the getters and the setters for the two properties? Okay, cool.
Can you scroll up? Let me see the top part, please. That's fine.
Can you guys now code a display function to display mug ID and mug price? Non-static, just like in the previous example we did. A display function to display mug ID and mug price. Okay, so it's one method that simply displays both properties. And similarly, create a non-static set mug data function to set mug ID and make mug price values. Very similar to how we did it in an employee. So we had a change all employee properties. So we just passed all the parameters to it, which we then call the respective setters to change the class properties. So once you're done with the set mug data method, and then write the main method where you run some tests similar to how we did in the employee class, declare some objects, call the different methods to see how it behaves, to see if you can get everything done. Does it behaves the way you want it to behave?
Working fine for me.
So I'll just do one. And that showed me the default. If I pass a different kind of a value, like only one parameter of type number, then that's mug ID. And okay, if I pass a price, then the price. If I pass both, then it's both. So I just basically tested in one line all 4 variations. And to test my set mug data, I could just say m1 dot set mug data. I'll pass the 2 parameters, and I'll just call the display method again to make sure that the values have changed. And they did change from 7719.66 to 10555. Okay. So what are your thoughts about what you guys learned so far?
I'll say it's a little bit tricky, but if you learn where to put certain things, it'll work out fine.
Okay. So Desmond, do you seriously believe that this should be the Java mascot because it's tricky?
Man, yes, 100%.
Okay.
As long as you're the one who's like doing the commercials, I'm all in, man.
I mean,
Yes.
just remember, tricks are for kids.
Okay, so what I will do next is I will put you guys in breakout rooms and I will ask you to solve a problem. If you go to the end of the chapter where you have programming exercises, go to the end of the chapter, look at programming exercises, and read question number 1. In the meanwhile, let me create your breakout rooms. I'm going to put you in breakout rooms for 20 minutes to solve this problem. So you will be team coding. So one of you could share your screen and the other person can direct. And you can just solve the problem together. It's a very simple problem. It is asking you to create a class called sandwich with a few properties and getters and setters. And then it is asking you to not create the main in the same class. Create another class called test sandwich, and your main will be there. And let me show you in my example here how that will be done. You know, for example, I had my main over here, right? So if I cut it out from here, okay, and let me create a new class called, I want to test mug. That will be my new class. And I'll paste it here, the whole main. and run it, it works exactly the same way. So you can write main in the same program, or you can create a separate program and write main there. It works exactly the same way, as long as you're running the program with the main. This will be in your ebook towards the end of the chapter 3 and oh, sorry, 4, and that should be somewhere around page 157.
Okay, thanks. I was looking in chapter 3.
Oh.
Whoops.
Okay, so here I am opening your rooms. Okay, so room 1, Alvin, Lewis, Zach, got it?
All right, well, yeah, Lewis
Yeah,
is
I'm just
up, I think.
finishing it up.
Okay, Aiden and Daniel, room 2.
Yeah, we got it.
Yeah, it's all good.
Okay, JC, Jonah.
I had gotten it, but Jonah was stuck at a point.
Okay,
Yeah, I got stuck.
okay, okay. And Miguel and Nathan.
I personally got to just about when we were creating test sandwich, but
Okay. Jacob and Jonathan.
Got about halfway done, but I slowed us down considerably, unfortunately.
Okay, okay. And Desmond and Jack.
Wait,
Wonderful.
which one were we
Wait,
supposed to do again?
We were trying to ask which one we were doing number 4. Was that what we were supposed to do?
No, number 1, sandwich.
Oh,
Yeah,
well,
we
that
were doing
explains
blood
why
work.
we only got one part of it done.
Okay. Ethan and Taddy.
So we got most of it done, but I couldn't figure out how to prompt the user for like the main ingredient, the bread type and the price, and then assign it to that variable. That's what we were
Oh.
struggling with, but we got the getter, the setter, and then we were able to instantiate one subject or one sandwich object and then display the value for it. But there weren't any values because we couldn't figure out how to read them in.
Okay, so it's well, basically you'll do it the scanner way that you typically do. So we have data fields with main ingredients. We need a string for the main ingredient, a string for a bread type, and a price. So we need how many? 3 of them, right? So we need private string main ingredient, private string bread type, and then private double price. Include methods. It doesn't ask for constructor. So you did not have to create a constructor because the problem doesn't ask for one. So public void set main ingredient. Okay, so oops. Okay, so that completes the class, right? With fields and getters and setters. Now let me create the other class, which is called test sandwich with a public static void main. So it is asking you that to prompt the user for values. So I'll be needing a scanner object, scanner, or I can actually bring in my chapter 3 knowledge here, public static string input. So I need to declare an instance of sandwich type. So SW1 equals to new sandwich. So I create my object. Now comes the question, how do I go about passing the values from the user for data and instantiate one of the objects and display its values? So I can say sandwich1 dot set main ingredient. Oops. Set main ingredient. And in the parameter, I can just make a call to input and say the message is please enter main ingredient. So this is where you can bring in the knowledge that you have already acquired in the previous week. And then you can have a setter for bread type and please enter bread type. And then you can have a setter for price. In that case, please enter price, but price is double. So that's why you will do double dot parse double, and then you will pass the parameter. So all of that knowledge can be brought here, and then you can display the values back to the user. So now when I run this program, it asks for a main ingredient, tuna, bread type white, and price is 588. And here you go. Okay. Does that make sense to you guys? What I just did here? So I basically shortened the process, sort of kind of reviewed what we did last week and brought the knowledge here. So the more you see, the more times you see, the better you get at it, basically. So I coded a little bit faster because you guys were familiar with the problem. So I just coded the class with properties and getters and setters, didn't write the constructor because it didn't ask for one. And then here's the main separate from the class. So for those of you who did not get the prompt logic, does that make sense to you now? How you prompt the user? Ethan, did you ask the question about prompt, right?
Yeah, I did. I copied the code you did and it's not asking me for where it says like, please enter main ingredient. It's not doing that on mine.
Okay, let's see. Okay. Can you share your screen?
Might I add though, I only have one class for it. I didn't create a second class named test
Okay.
sandwich.
Okay. Actually, okay. So you're making a call. Oh, it tells you there. If you look at the bottom, it says, please enter main ingredient. Just click there on the line and start typing.
Oh,
Yeah,
oh.
type an ingredient.
Why does it have, oh,
Oh, yeah, because of that.
oops.
Yeah.
Okay. Okay, duh. Alrighty.
Just type something and let's make sure that it is taking the input. Yeah, enter. Yep, cool. It works fine. Okay, cool. Oh, your output is not coming right. Because your display method, display sandwich. Okay, let's see your display sandwich
Right here.
right here. So you're displaying oh, look at your lines 54 and 55. You're setting, no, look at line 54 and 55. The second one should be set bread type.
Oh,
And the last one should be set price. And then when you do set price, you have to cast. So I will share my screen with you again so that you can see the casting code. Line number 9.
okay, I have to double that parse.
Okay, now for the rest of you, go ahead and go to the units and go to the unit 3. This week's homework problem is a little bit different than from the previous weeks. So I've given you 2 sets of problems as 2 separate deliverables. The first deliverable is create a Java program called Professor, and I'm asking you to create 5 properties and create a getter and a setter for each property, and then write a main method very similar to the sandwich example, right? But you know, I'm not asking you to take an input from user, just create an object, just one object. Not even asking you to do the constructor, nothing, just, and then hard code the values or whatever you want to do with getters and setters and display them. I've given a sample output over here. Just wanted to make sure so that you know what should your output look like. So I'm explaining that because at times students ask me, do I have to enter these values? No, it's just a sample set of values. Okay. The other part is that I have created an 8-step solution already. I want you to watch each step and redo it. So when I'm doing each of the steps, I'm doing it with an explanation. So I'm not giving you here a new problem to solve. Rather, it's pretty much like you following me in a tutorial in class. It's in a similar setup. Okay, so you replicate all the steps that I do. So this week's assignment a little bit easier.
So is the 3B assignment kind of more like an in-depth explanation for the way we?
It's pretty much like when I do an example in class, I do one step, I go back and modify and explain, and then it's in the same lines.
Okay.
Okay, so you're pretty much following my example. So you will only turn in your final version after step 8. You don't have to turn in the first 7 steps, but you got to do the first 7 steps to do the step 8.
Makes sense.
Okay, but you will only turn in step 8. So the knowledge that you will acquire in step number like in assignment 3B and 3A, the reason I did not give you a full-blown problem to solve yourself, because I want you to do a little bit more practice. And then when you come back next week, the problems that I'll assign you next week, I want to build some solid foundations for you to be able to do things on your own. Because again, it's a new language, you're still learning new stuff. So next week we go into if conditions and loops and stuff like that. So you'll be learning something old from Java's perspective. Then we're going to marry that with object-oriented programming and modularization that we learn in chapters 3 and 4. So that's basically what I'm trying to do here, just so that you know what I mean. Okay. So I hope it was a good learning day.
Have a good one.
And you guys have a good night.
You too. See you tomorrow.
You as well.
Yep. See ya. Take care. Bye.
I just have a quick question about tonight's homework assignment.
The one that's due
Uh,
tonight? Okay.
Yeah, I got like my code and everything done. I'm just gonna share my screen.
Mhm.
Does